Okay. Good morning, everybody. Mehak, Lengsun, and Rodvisa. 3 people are present here, so we can start. Rodvisa, can you hear me?
Yes, sir. Yes.
Okay, very good. If you can hear me, I hope everybody can hear me. Guys, let's continue. As I told you yesterday, we will continue with 4.4 undetermined coefficients, superposition approach. And 4.5 undetermined coefficients, and in a later approach, I will skip this since actually they do the same thing, but just 2 different methods. All right. You can study yourself, but I'm not going to ask any question from 4.5. If you're interested, you can learn it. So today we will talk about undetermined coefficients, superposition approach. Waiting room, 2 more people are joining. Okay. So review theorem 4.1.6 and 4.1.7. And if you just need to, if you remember this, or if not, you can have a look at these theorems. What is it about? If you remember, these theorems are about if you are solving nth order linear differential equation. And we are talking about this equation, all coefficients are constant, right? And number one, we need to solve 2 different equations. Number one is the homogeneous one. Here we have homogeneous equation 0, and the second one is non-homogeneous. And we'll just combine this, right? Because first, when we just solve this homogeneous equation, right, we get, what is it, a complementary solution. And after that, we need to find non-homogeneous equation. Actually, we complement solution, and after the particular solution, and their sum actually gives us all the solutions. That gives us the general solution. Anyway, today we will focus on this differential equation again. What is it? It is nth order, and because highest order of differentiation is n, that's why it is nth order. And here we have all the coefficients are constant. When it is not constant, we will talk about this in the next section, lecture. Okay, all these coefficients, a sub n minus 1, blah, 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 a sub 1, a sub 0, these are all constants. Okay, so to solve this non-homogeneous linear differential equation, when it is homogeneous, right, in the previous lesson, we have already learned this, how to solve it. But here, when it is non-homogeneous equation, we must do 2 things, or we must follow 2 steps. Number one is find the complementary function y sub c. And we know how to find this complementary, right? To find this complementary solution, and we need to solve that homogeneous part. Here we just put 0 and solve this. How do you solve this? If you remember, we need to form this auxiliary polynomial equation, and we have to solve this, and after that write the solutions. After that, find any particular solution of the non-homogeneous equation. Now here, instead of 0, now we have g of x, that's our original equation, and we need to find any non-particular solution of this equation. And after that, the general solution will be complementary solution plus particular solution. Okay, so we have already learned this part. Now today we are going to learn how to find this, what is it, particular solution. Okay. All right, method of undetermined coefficients. This is the method we are going to talk about today. So the main idea behind this method is a conjecture about the form of this particular solution. And to find this one, actually, we are going to make an educated guess. Okay, so that educated guess depends on the form of this g of x. Okay, so the general method is limited to linear differential equations such as number one is, we are talking about this equation, keep it in mind, with number one is this, all the coefficients, this a sub i's, right, a sub 1, a sub 2, a sub n, even a sub 0, they are constants. And number 2, this g of x. What is g of x? The function on the right hand side, either it is constant, m is equal to 5 or 7, or polynomial function. Actually, it's constant, also polynomial function. But here, when we say polynomial function, people may not think of this constant number. That's why we are emphasizing that also it's a constant function. Okay, an exponential function, what is it? E to the power alpha x, or a sine function, something like sine of beta x or sine of alpha x, or cosine function, cosine of beta x, or finite sums and product of these functions. What does it mean? Well, g of x is either constant, polynomial function, you know what is a polynomial function, exponential function, or these trigonometric functions, sine or cosine, or finite sums and products of these functions. That means that maybe it is 5 times sine of x, or sine of x times cosine of x, for example, or sine of x times e to the power 3x, for example, or let's say our polynomial is quadratic function 3x squared plus 5x minus 2 times e to the power alpha x, or the product of this constant and the polynomial function and exponential function and the sine function, cosine function altogether. Okay, we are just going to consider this case here. So some examples for the form of g of x is this. For example, g of x equals 10, or g of x equals x squared minus 5x, or it is 15x minus 6 plus 8 times e to the power minus x, or sine of 3x minus 5x times cosine of 2x, or x times e to the power x times sine of x, plus 3x squared minus 1 times e to the power minus 4x. These are just some examples about the forms of this g of x. Okay, as you see here, in each case, either this is what is it? Constant, right? This one is polynomial function of degree 2. Actually, it's just quadratic function. And this one is, what is this? The combination, right? Or the product of this. Here, 15x minus 6. That is p of x plus 8 times e to the power minus x, right? And here we have cosine and multiplied by polynomial function, blah, blah. So that is g of x is a linear combination of functions of the type, this polynomial function, or this p times e to the power alpha x, or p times e to the power alpha x sine of beta x, and p times e to the power alpha x and cosine of bx, or their sum. Okay, here of course n is non-negative integer. It is from the definition of this polynomial function, right? When we are defining a polynomial, right, we have a condition that this n is a non-negative integer. Otherwise, it cannot be polynomial. If n is equals any negative number, for example, it cannot be a polynomial function. So the method of this undetermined coefficients is not applicable to equations of the form 1 or form 1, where this g of x equals natural logarithm of x, or 1 over x, or tangent of x, or sine inverse of x. Okay, we are now going to consider these kind of functions. So we are now here, we're going to consider only these types. And these things, we'll talk about them later. Okay. All right, guys, to do this one, you need to be very good and very fast about identities. I don't know if you have if you can remember, you learn identities in pre-calculus, or if you didn't take pre-calculus, you must have learned this at high school. Okay. In this example, I will show you how we should approach this, and the speed is really important. Otherwise, it takes a lot of time. Let's start with this example. General solution using undetermined coefficient. Okay. So actually, assume that this is y of x is a general solution, which is equal to the particular solution plus complementary solution, right? So first, in our first step, we will solve the homogeneous part of this differential equation. What is it? The homogeneous is y double prime plus 4y prime minus 2y is equal to 0, right? And if you just solve this, it gives us the particular, what is it, complementary solution of this equation, right? So to do this one, we know that we need to form our auxiliary equation, that m squared plus 4m minus 2 is equal to 0, right? and it's just a quadratic equation. It is m squared plus 4 times m minus 2 is equal to 0. So from here, can we solve by multiplication, factorization? I don't know. So delta is equal to 16 plus 4, negative 4 times negative 2, it is 8. That's equal to 24, right? Now from here, I can find that m sub 1 equals negative 4 plus square root of 24 over 2. And the second solution is n sub 2 equals negative 4 minus square root of 24 over 2. Now we can simplify this, right? It is 2, 4 times 6, so square root of 6 minus 2, or anyway, minus 2 plus square root of 6 minus 2 minus square root of 6. Okay? Then the solution will be, what is it? I can just write here that y, the particular solution, right? That complementary solution will be, what is it? C1 times e to the power minus 2 plus square root of 6 plus c sub 2 e to the power minus 2 minus square root of 6 x. Right? Okay. This is particular solution. Okay, so that is our first step. Now, in the second step, we'll look for complementary solution of this differential equation. Now we need to solve this differential equation. Y double prime plus 4y prime minus 2y is equal to 2x squared minus 3x plus 6. Right? Okay, because this one is here, this particular solution, if I substitute here, it gives us 0. Now when I substitute here, right, it gives us this thing. Okay. So on the right hand side, what we have here? We have just polynomial function of degree 2, right? Here we have p of x only. Okay. So now we need to make an educated guess. So what function should be this y, so that if I just differentiate twice and differentiate once and multiplies by 4 and multiply that polynomial by negative 2 and just do evaluate this, it produces quadratic function. Right? So we know that now first it does not involve any sine of x or cosine of x, right? So our educated guess will be here, this y, okay, this complementary solution y is y, it should be, this is quadratic, also it must be quadratic function, something like this, ax squared plus bx plus c. Now I'm assuming that this is the form of this complementary solution. If I substitute here, differentiate twice, right? Differentiate once, and here we have quadratic function. And if you just simplify this, what do I get here on the left hand side? We get again quadratic function, right? Or polynomial function of degree 2. On the right hand side, we have polynomial. On the left hand side, we have polynomial. Then we are assuming that for every value of x, left hand side is equal to right hand side. And I can determine these coefficients, this A, capital B, capital C. Right? So now, since I'm assuming that this satisfies this equation, so I need to, when I substitute here, it must produce identity, right? Identity means left hand side is equal to right hand side for every value of x. So number one, differentiate twice. So let's do substitution. First, if you differentiate this, what we have here? 2 capital A x plus b, right? And if you differentiate twice, here we have 2 times capital A, and this is equal to 0. If I substitute here, what we have here? 2 times capital A, this thing, plus here we have 4 times, what is y prime? That's equal to 2 capital A x plus b, right? And here we have minus 2 times y. What is y? That is ax squared plus bx plus c. And on the right hand side, we have this function 2x squared minus 3x plus 6, right? And what is it? It's just an identity, right? Identity means for every value of x, left hand side is equal to right hand side. So I need to determine these letters now. Before we continue this, let me just simplify this and write this in standard form. Also, without doing this, I can do this, but it's a bit, it looks messy, right? So if you just write it in standard form, negative 2 times a, right? Ax squared. So we do not have an x squared here. So here we have minus 2ax squared. Okay. And how about x? Here I have x. Here I have x, right? So here we have 4 times 2. It is 8a plus 8a, right? And here we have negative 2 times b minus 2b and the x, right? All the terms which has x is here, right? Now we have constant term plus, here we have 2a, and here we have 4 times b plus 4b, right? And here we have negative 2 times c minus 2c. That is a constant term of the polynomial on the left hand side. And on the right hand side, still we have this thing, okay? And let me just write, still we have this thing on the right hand side. So now, since we are claiming that these two things are identically equal, right? The corresponding coefficients also must be equal to each other. That means that the coefficient of x squared is here negative 2 times a, but here it is 2. They must be equal, right? So here we have minus 2a should be equal to 2. And here we have 8a minus 2b should be equal to, what is x here? It is minus 3. And here we have constant, right? That is 2 capital A plus 4b minus 2c should be equal to, on the right hand side, constant term is 6, right? So from here, we get a is equal to negative 1, right? Now we know a. Now from here, if we calculate b, here we have negative 8, take to the right hand side, negative 3 plus 8, that's equal to 5, divided by 2, so it is minus 5 over 2. Right? So I need to find c here. What is c here? 2 times a, it is negative 2, and 4 times b minus 10 minus 2c is equal to 6. Or c is equal to minus 12, take to the side, it is 18. 18 is divided by negative 2, it is negative 9. Now we have determined these coefficients, right? So that is a equals negative 1, b equals minus 5 over 2, and c equals negative 9. So if I substitute here, then this complementary solution will be a negative 1, so it is minus x squared, right? And b minus 5 over 2x, and c it is minus 9. Okay, and dots, dots, dots. Then the general solution of this differential equation with constant coefficients will be particular solution plus complementary solution. And what is particular solution? We got it here. So that is equal to this thing, right? It is C1 e to the power minus 2 plus square root of 6x plus c sub 2 e to the power minus 2 minus square root of 6x plus plus now complementary solution. What is it? Is equal to this. So that is, let me just write in parentheses so we can see this, minus x squared minus 5 over 2x minus 9. Okay. So that means that if I substitute here, right? See here, if I just substitute here, what we have here? Here we have y particular plus y complementary and double prime plus 4 times y particular plus y complementary prime minus 2 times y particular plus y complementary equals, that is our polynomial function. I can reorganize this one, right? This y p double prime plus 4 times yp prime minus 2 times yp prime is equal to 0, right? If you just substitute this thing here. And this complementary solution, because of this, right? If you substitute here, it produces this g of x. Okay? And this method is called, what is it? Method of undetermined coefficients. Okay, Rotvisal?
Yes, sir.
Too easy? Or it's okay?
No, no, it's not easy.
It's not difficult, but it is not so short. But this is very simple example. Here on the right hand side, we have just quadratic function. Now, if I have assumed that quadratic function times e to the power x, for example, or quadratic function times sine of x, it will be much longer. But actually, we are just following fixed rules. But it's a bit long. But you should just be careful with your calculation, and that's all. Okay.
So we are chapter 4 up here in the midterm, right?
Sorry.
Chapter 4 will be in the midterm too, right?
Yeah, of course. So you will have midterm after we finish chapter 4, or maybe after, I will see, okay, because you will have midterm from chapter 3 and chapter 4. Now I'm thinking how to do your midterm, okay. Maybe should I give you some kind of project or some different sets of questions, or I'll just do this online. I haven't decided yet, because as you see here, the differential equation, the solutions are long. I cannot ask them as a, or is it multiple choice question? Maybe I'll just ask you and you need to solve this and scan your solution and just attach it in the system. I will see. Okay, I'm thinking now. I will let you know soon.
Wait, so our midterm will not be tomorrow.
No, not tomorrow, next week.
Okay, thank you.
Okay, your midterm is next Thursday or next Friday. Okay, or
Yes,
maybe
sir.
next Saturday, we will see. But next week, it will be next week. Okay. And also, we missed some classes because of public holidays. Also, we may have some compensation class this week. Okay, maybe Friday. Maybe if you are free, you can participate. Otherwise, I'll just record the class and share it with you on YouTube. Otherwise, we have no choice. Or if you say, just say that, okay, we have free time. During this free time, we can come together and teach you. But if you prefer that, you'll just watch yourself, and I will just record it and put it on in YouTube. Okay. Anyway, guys, let's talk about this. But this week we'll have some compensation class, maybe 1 hour or 2 hours. 2 hours means 2 sessions, 30 minutes, 30 minutes. But today and tomorrow we will have class. And your midterm is next week, either Thursday or Friday or Saturday. Depends on when you will be free. Okay. All right. Another example. Particle solution using undetermined coefficient. So now we'll just speed up. We got the idea. So on the right hand side, it's not equal to 0. That is non-homogeneous equation. So first we have to form our auxiliary equation. Let me change marker. We never use black. Let's use black today. Okay. The first one is, what is this? The first step. So we need to solve this equation. M squared minus m plus 1 is equal to 0. That is the auxiliary equation of this homogeneous equation, right? Y double prime minus y prime plus y is equal to 0. So if you solve this, what is it? It is delta equals 1 minus 4, that's equal to -3, right? And from here, m1 equals 1 plus square root of 3i. What can I write here? I square root of 3. No. Just write it as square root of 3 times I. And m sub 2 equals 1 minus square root of 3 I. Right? That is alpha plus beta, alpha minus beta, right? And we know how to write this solution, right? So what will be the solution of this? It will be that particular solution of this differential equation will be, what is it? E to the power x, right? Because of this, e to the power x times, and here we have a times, maybe I should write here, not a, c sub 1, we are going to use a later. So here we have c sub 1 times cosine of, what is it here? Square root of 3. Plus c sub 2 times sine square root of 3x. Right, Sareput, is it correct?
Yes, sir. And also minus sign, minus sign in the middle.
Minus sign? Where?
Oh, no, sir, no. We don't have minus sign.
Here?
Yes, sir. Maybe I confused. No, there's no minus sign.
Okay. We have 10 minutes left. Okay, let's just continue a little bit, and after that, a break. Okay, that's our particle solution of this differential equation, right? Now, we need to solve, we need to find, what is it? Complementary solution. So to find complementary solution, now we need to solve this part, y double prime minus y prime plus y is equal to 2 times sine of 3x. Okay. So interesting, actually, what function should we have here, so that if I just differentiate twice and once and itself, and sum of this gives us sine of 3x. Usually only this sine and cosine and the exponential function, they have this property, right? Because if you just keep differentiating them, they produce either itself, or for example, if it is trigonometric function, differentiate sine once, it is cosine, differentiate one more time, it is sine. How about e to the power x, for example? If you differentiate many times, always the differentiated function contains the original function. So since here we have like this, our educated guess would be here that particle complementary solution must be of this form: a times cosine of 3x plus b times sine of 3x, because here we have 3x, that's why there's 3x, okay? And it's not just sine of 3x, okay? If we have just one trigonometric function, we always look for it in this form. If it does not involve this part, then b will be equal to 0. If it doesn't have this part, then a will be equal to 0, okay? And we'll see. So now I'm assuming that this complementary solution must be in this form. All right. Now if I just substitute here, y prime is equal to, differentiate this, here we have minus 3a times sine of 3x plus this one is 3 times b cosine of 3x, right? And one more, because differentiate twice here, second order. One more, here we have minus 9a cosine of 3x, and here we have minus 9b sine of 3x. So now when I substitute here, it must produce this, right? So let's substitute here. If I substitute here, this one is what we have here, sine of 3x, okay, minus 9a cosine of 3x minus 9b, and here we have sine 3x, right? And minus, here we have y prime. What is y prime? Is equal to this. So when it's minus, here we have plus 3a times sine of 3x, 3a times sine of 3x, and minus this, it is minus 3b cosine of 3x, right? And the plus, we have y. What is y? Y equals this. That is a times cosine of 3x plus b times sine of 3x. And on the right hand side, we have 2 times sine of 3x. Okay. So let's just organize the left hand side. And here we have cosine of 3x. Let me just write here minus 9a, right? Cosine of 3x. This is cosine of 3x. And here we have cosine of 3x. And here we have cosine of 3x, right? Okay. So cosine 3x, that is minus 9a. The second one is minus 3b. And third one is plus a times cosine of 3x. Right? Plus, how about sine minus 9b minus 9b. Oops. Minus 9b, and here we have plus 3a, and here we have plus b sine of 3x. On the right hand side, we have sine of 3x. Okay, this is not an equation, this is identity actually. They are assuming that they are identically equal. Okay, so to do this one now, on the right hand side, do we have cosine of 3x? No, right? So that means that this thing should be equal to 0. So if I simplify this, negative 9a plus a, so it is minus 8a minus 3b, it must be equal to 0. And how about the coefficient of this sine of 3x? Sine of 3x, it is this, so that's equal to 3a, right? Minus 8b should be equal to what? 2. So it's just simultaneous linear equations. We have to solve this. How can I solve this? First, multiply this by 8. So here we have minus 64a minus 24b is equal to 0. Multiplies by 3, 9a minus 24b is equal to 2. It is equal to 6. Okay. So if you just subtract this, 9a minus minus 64 is equal to 73a. And here we have 6. 6 minus 0 is equal to 6. So from here, a is equal to 6 over 73. Right. If you didn't make any mistake, why is a kind of weird fraction? Anyway, now we need to find b. What is b? b equals, if I just substitute here, minus 8 over 3, minus 8 over 3, it is minus 8, minus 8 over 3 times 6 over 73. 6 over 73. Right? That's equal to minus 16 over 73. All right. If it is wrong, check it in calculation if you made a mistake. I'm not sure about this fraction. But anyway, we have just found this. So our complementary solution, this complementary solution will be, what is a? A equals 6 over 73 cosine of 3x minus 16 over 73, it is sine of 3x. Then dots, dots, dots. Okay. Dot, dot, dots. Then the general solution of the given differential equation will be particular solution plus complementary solution. And that's equal to, what is particular solution? It is this, right? Plus complementary solution, it is this. Okay. We don't have enough space, so it will be the sum of this particular and complementary solution. Okay, Mayhak, are you there? Mayhak, sleeping? Okay, maybe he's away from the laptop. Guys, now let's have some break. It's almost 40 minutes, okay? After 10 minutes, we will continue. See you in the next session.
See you.
See you, sir.
See you.